Hello, my name is Sharon Pruitt. Today, I am conducting a repeated measures ANOVA to determine whether chocolate has a significant effect on attitude over time. The research question is, does attitude significantly change across 4 time points? Pre-test, 5 minutes after eating chocolate, 1 hour later, and 4 hours later. Because the same participants were measured 4 times, a repeated measure design is appropriate. The null hypothesis states that there is no difference in mean attitude scores across the 4 time points. The alternative hypothesis states that at least 1 time point differs significantly from the others. We will now set up the analysis by going to Analyze, General Linear Model, Repeated Measures. I will place within the within subject factor name time, and we will place 4 in the number of levels box, and it's already been added. Now we'll go to define, and we will move attitude over into the within subjects variable. Click on EM means, click on time, move it into the display means for, click compare main effects, and click continue. I'll also click on options so that we could get descriptive statistics and estimates of effect size. Click continue, okay. Each participant has 4 scores, which we listed. Attitude _0 was pre-test time. Attitude _1 was for the 5 minute time period, and so forth and so on. Because the same participants are measured repeatedly, this violates independence across time points, which is why we must check the assumption of sphericity. One critical assumption in repeated measures ANOVA is sphericity. Sphericity means that the variances of the differences between all combinations of time points are equal. In simple terms, the spread of score differences between pretest and 5 minutes should be similar to the spread between pretest and 1 hour, and so on. To test this assumption, we examine Mauchly's test of sphericity. In this analysis, Mauchly's W is 0.860. Chi-square is 3.114. We have 5 degrees of freedom, and sig, which is our p-value, is 0.683. Because the p-value is greater than 0.05, the test is not statistically significant. This means we fail to reject the null hypothesis of sphericity. Therefore, the assumption of sphericity is met. This is important because when sphericity is met, we use the sphericity assumed row in the test of within subjects effect. If the test had been significant, meaning if P had been less than 0.05, we would instead interpret the greenhouse geyser or the Hunt-Phelps corrected results. Since P was equal to 0.683, we proceed with the standard sphericity assumed row. Now I interpret the sphericity assumed row. F with 3 and 66 degrees of freedom equals 5.681. P is 0.002, and partial eta squared is 0.205. The repeated measures ANOVA shows a statistically significant effect of time on attitude. F with 3 and 66 degrees of freedom equals 5.681. P is equal to 0.002. And as we mentioned, because P is less than 0.05, I reject the null hypothesis. This means that attitude significantly changed across at least one of the 4 time points. Next, I examine effect size using partial eta squared. The partial eta squared value is 0.205. Using conventional benchmarks, 0.01 equals small, 0.06 equal medium, and 0.14 equal large. A value of 0.205 indicates a large effect size. This means time explains approximately 20.5% of the variance in attitude scores. This is not only statistically significant, it is substantively meaningful. Noting the mean in our estimate marginal means, we see for the pretest, the mean was 76.57. After 5 minutes of eating the chocolate, the mean increased to 83.87. Then 1 hour later, the mean decreased to 79.087. And 4 hours later, the mean was 78.44. We see that attitude increases sharply 5 minutes after chocolate consumption, then declines somewhat at 1 hour and 4 hours, though still remaining slightly above the baseline. Now I examine which specific time points differ significantly. The key significant comparisons seem to exist between time 1 versus time 2, p-value of 0.001, then time 2 versus time 3, p-value is 0.010, and then time 2 versus time 4, the p-value is 0.005. The significant differences involve the 5-minute condition compared to the other time points. You see the p-values of the other time points are greater than 0.05. This suggests that chocolate has an immediate positive effect on attitude, but the effect diminishes over time. While the results are statistically significant, it is also important to consider practical meaning. The increase from 76.5657 to 83.87 represents a noticeable shift in attitude. However, the effect appears temporary as scores decreases over the next few hours. This suggests that chocolate may provide a short-term mood enhancement rather than a sustained improvement in attitude. In real-world terms, chocolate may boost immediate mood, but it does not produce long-term attitude change. A repeated measures of ANOVA revealed a significant effect of time on attitude with an F value and with 3 and 66 degrees of freedom equals 5.681. P equals 0.002. And Mauchly's the partial eta squared was equal to 0.205. Mauchly's test of sphericity was not significant. P equals 0.683, indicating that the assumption of sphericity was met. Pairwise comparisons were revealed that attitude significantly increased 5 minutes after chocolate consumption, but declined at later time points. In summary, the repeated measures of ANOVA showed that chocolate had a statistically significant effect on attitude over time. The assumption of sphericity was met according to Mauchly's test, allowing interpretation of the standard within subjects' results. Attitude increased noticeably 5 minutes after chocolate consumption, but gradually declined over the next several hours. Although the effect size was large, the pattern suggests that chocolate produces a short-term improvement in attitude rather than a sustained long-term change. This concludes my video.